Hello and welcome to physics. We're going to start off by studying the basic concept of motion and all the definitions and everything we need to know regarding that. Before we can do anything in physics, we need to define the following two definitions: a scalar quantity and a vector quantity. These are important for all physics sections, whether it's motion, whether it's electricity or waves or anything like that. So it's very important to take note of the following. Firstly, if we look at a scalar, what is a scalar? A scalar is a physical quantity that is completely described by its magnitude or its size. Now, examples of this is area, okay, density, distance, energy, mass, speed, temperature, time, volume, and work. I do not say run 6 seconds up, okay, or it just took me 20 minutes north. Okay, time doesn't have a direction. I don't say my mass is 60 kilograms west. Okay, mass doesn't have a direction. So all these quantities can be described by just naming the number, the size, and not a direction specifically. Vectors are physical quantities that are completely described by its magnitude and its direction. So vector quantities are acceleration, displacement, force, magnetic polarization, momentum, position, thrust, velocity, and weight. Now, weight and thrust are both forces, so they fall under the force category. Position and displacement also goes very close together. In our study of motion, we are going to look specifically at distance and displacement and also position. Before we can determine distance or displacement, the first thing that we need to describe is position. Now, we have to kind of know where we're starting off with. If I tell this guy to run, the first question he's going to have is, where to must I run? Must I run towards the tree or must I run towards the house? Is there a direction I need to run? The second thing, to be able to define that, we need to define the starting point. So if I drag the guy over here, okay, we can see that he's now basically standing at 0. Now, this position is in the middle between the tree and the house. That is his position. And that's the first thing that we need to define. Where is an object? Okay, the object, the guy is standing in the middle. The tree is to his left and the house is to his right. Now, in this number line at the bottom, we made towards the tree negative and towards the house positive. So if he moves 8 meters in the positive direction, he goes to the right. And if he starts at 0 and he moves 8 meters in the negative direction, he goes towards the tree. Now, distance is the total amount of meters moved independent of direction. Okay, so if our guy walks 8 meters to the house, that's 8 meters, and then he walks 16 meters to the tree from the house, his total distance is 16 plus 8, which is 24 meters. And that is distance. It's the total amount of meters traveled or moved independent of direction. Therefore, we just add everything together. Now, with regards to displacement, the definition of displacement is a direct distance from where the person or object started up to where it ended, including the direction. Okay, so we know now that the person started here and ended there. So he moved 8 meters to the left. So his displacement is 8 meters left of where he started. Okay? And if we go in terms of a number line, we made this way positive and negative. We can also say 8 meters in the negative direction. So negative 8 meters. That would be his displacement. So his distance when he moved to the house and back to the tree was 8 plus 16. But his displacement was only from here to there. We could also say positive 8 because it's 8 in the positive direction and 16 in the negative direction gives me negative 8, which is 8 meters to the left. Okay, either way, we calculate how far he has been from where he started to where he ended. Okay, so remember, a displacement is a vector quantity, so we need a magnitude. So the magnitude is the 8 meters, and then we need a direction, and the direction is indicated over here, which is the left or the negative over there. So displacement is dependent on direction. If it's in opposite directions, we subtract. If it's in similar directions, we add. Okay? But with distance, we always add. Whether it's in this direction or in that direction, we just keep on adding. Okay, and that's the main difference between displacement and distance. Next, we will be looking at speed and velocity. As we know, speed is a scalar quantity, so it doesn't need a direction. And in physics, we can describe or define something if we put the formula in words. Now, what you have learned up to now is that speed is distance over time. Okay, and the speed of an object is the distance of an object in a specific amount of time, or divided by a specific amount of time. So let's say our guy runs to the house and then to the tree in 10 seconds. What is his total distance? Okay, the speed is going to be the distance over time. His total distance is 8 plus 16, 24 divided by 10, and his speed is 2.4 meters per second. Very important to be able to calculate that. Now what we will see is some of these symbols might change a little bit. We use the symbol S quite often, so we use in physics IG, we use this letter V, okay, which we're going to look at just now. So velocity is then defined as the displacement over the time, the displacement of an object moved in a specific time. And this velocity and speed can differ if there's a change in direction. So here, instead of going, the direct line from where he started to stop was 8 meters to the left. Okay, so he had a displacement. So here we use velocity. The symbol that we use for displacement is a S, not speed's S. So therefore, velocity and speed both uses a V, and displacement will use an S over time. Okay, and we say 8 divided by 10. So the velocity is 0.8 meters per second. Okay, it's still one motion. The speed that we just saw was 2.4 meters per second, and the velocity was 0.8 meters per second. It goes about your frame of reference. If you're looking at the total distance divided by the total time, or whether you're taking the displacement divided by the total time. So yes, velocity and speed is not the same concept, and also velocity is a vector, so we have a magnitude and the direction. So it's 0.8 meters per second to the left, or we would have had -8, and that's 0.8 meters per second negative, which means left if we chose the house's direction as positive. Lastly, we will be looking at acceleration. So acceleration is the rate of change in velocity. Now in physics, whenever you hear this word rate of change, that means divided by time. So the change, or the rate of, not the rate of change, the rate of means divided by time. Okay, it's what is divided by time? The change in velocity. Okay, so change can be represented by a little triangle, which we call delta. So we can also write the formula as delta V, change in velocity over time. But the change in velocity is when my car goes faster or when my car goes slower. So when I go faster, my final velocity is not the same as my initial velocity, it's bigger, and then I calculate the biggest one minus the smallest one, or the final minus the initial over the time. When I'm slowing down, my initial is bigger than my final, but I still use this final minus the initial over time, and then I calculated if I'm going slower, I will have a negative acceleration, which means I'm decelerating, I'm going slower. If I'm going faster, it's a positive acceleration, which means I'm going faster. If you have any questions on this topic, please let me know. Thanks, have a nice day.